Hi, my name is Ayushi Rastogi. I'm an assistant professor at the University of Groningen. This talk is on the promises and perils of inferring personality on GitHub. It is a joint work with Frenk then a master's student at TU Delft, and Professor Andy Zaidman, also from TU Delft. Let's start with what is personality? There are many definitions of personality in psychology, but in simple terms, it can be described as follows. This is me. How I think, feel, and act is an indicator and a reflection of my personality. To infer personality, one of the widely used model is OCEAN, also known as the Big Five or the five-factor model. Here, O stands for the openness to experience. Openness to experience characterizes intellectual curiosity, imagination, and open mindedness. Its opposite is close minded, lack of creativity, and intellectual interest. Likewise, the other four traits are defined. Conscientiousness is characterized by order, structure, persistence, and responsibility. Extroversion is linked to social engagement and assertiveness. Agreeableness reflects as concern of others' well-being and social harmony. Finally, neuroticism is characterized by the tendency to experience negative emotions. Now that we know what is personality, how is it measured? There are two widely known methods. The first is questionnaire, in which people answer a series of questions, responses to which indicate personality. This is what we know as a gold standard to measure personality. The other method uses signals, for example, using the text written by a person as a means to infer personality. Such tests are also referred to as psycholinguistic tests or text-based personality tests. Now, talking about software engineering, as a field, there are many use cases to study personality, both individually but also as a team. For example, there are studies exploring contribution patterns, predict code review result, and even project success. Notably, most large-scale investigations apply psycholinguistic tests on SE communications data since they offer the flexibility to infer personality at scale, something that is hard to achieve via questionnaire. Please note that the psycholinguistic tests used in software engineering were trained on usual conversations or text. To this, SE communications introduce textual features that do not appear in a usual conversation and are otherwise a part of SE communications. Example, technical jargon. So, as studies exploring the role of personality in software engineering continue to grow, it is important to understand the promises and perils of inferring developer personality from SE communications data. Let's revisit how psycholinguistic tests work to identify potential factors influencing the inferential ability. In this process, there are three sources of variabilities: characteristics of the developer, text, and the model itself. So, to assess the reliability of psycholinguistic test for SE text, we study how the characteristics of developer, text, model, and their interactions can influence the inferred developer personality and how can we improve it. Our analysis is conducted on GitHub. Before diving deep, into the 4 research questions, let me introduce to you the 3 state-of-the-art and practice psycholinguistic tests widely used in software engineering and justification for the choice. We chose 2 models from academia, Goldbeck and Yerkoni. Goldbeck is trained on small size data, example tweets, while Yerkoni is trained on larger text such as essays and blogs. We also chose personality insights coming from IBM. Unlike the 2 models proposed in academia, this model is trained on a wide range of text sources. The model constantly evolves and is seen as a general purpose tool. Our first question investigates the influence of SE communications data on inferred personality. SE data is different from general conversations in 2 ways. 1. It has technical words which have different meaning than everyday use. Example, cookie. And 2. The use of GitHub flavored language. For example, text indicating markdown language. We identified 12 factors that can potentially influence inferred personality after looking from 4 perspectives. 1. Pre-processing steps used in previous studies, example URL. 2. Terms in the dictionary that can be incorrectly represented in software engineering text. 3. Elements that raise privacy concern, example email address. And 4. Elements that can improve space or time efficiency, example variance of space. Here is a table from our study showing how removing a factor improved inferred personality scores and the percentage population influenced by a given factor. Our advice for future studies inferring personality are: 1. Remove platform-specific features, for example codes and code blocks. You will improve inferred personality scores. And we also recommend removing some other factors such as white spaces and email address, which, while do not affect personality scores, improve efficiency and lower privacy concerns otherwise. For all other questions, we applied the above pre-processing steps to minimize errors caused by them. Next, we explored if one model is better than another. We compared the personality scores inferred from the 3 models to each other and to the ground truth. Our study shows that the 3 models are comparable with error margins ranging from 25 to 48%. The 2 exceptions are PI agreeableness and Goldbeck neuroticism, in which case the error margins were as high as 68% at 95% confidence interval, rendering the results meaningless. Our advice here is to choose any of the 3 models unless specific traits are relevant. Next, we ventured into text sizes of 100, 600, 1200 and 3000 words to gauge its influence on the inferential ability. Here too, we compared the personality scores inferred with different text sizes for a developer to see if increased text size indeed improved the inference. Our study shows that the inferential ability of personality insights and Yerkoni is optimal at 600 to 1200 words and 1600 words for Goldbeck. Text with less than 100 words gives unreliable estimate, while beyond 3000 words we expect no further improvements. Finally, to assess whether the English skills of a person influence the inferred personality, for a subset of developers, we solicited information on English proficiency. 1. We classified developers into those whose mother tongue is English or not. This was an objective way to infer English proficiency. Also, we classified developers based on their perceptions of fluency in English. We compared the differences in personality scores for the developers based on their English proficiency. If the differences are high, English skills influence the inferred personality. Our study shows that fluency in English influences the openness to experience. Notably, many studies outside software engineering have shown that cultural background does influence openness to experience. We also found that PI and Yerkoni works best for non-fluent people, while Goldbeck for fluent people. This brings us back to the question where we started. Do psycholinguistic tests reliably infer developer personality from software engineering data? Our study shows that psycholinguistic tests can be administered to infer developer personality with an average error rate of 41%. Since the error margins are high, care should be taken to draw conclusions from the inferred personality scores. It also offers recommendations on how to improve inferred personality scores and introduces contextual factors, for example, English proficiency, which influences the inferred personality but cannot be controlled. Finally, we leave you with questions such as: should we infer personality in software engineering? And can psycholinguistic tests perform better on software engineering text? If you're interested in the answers to these and other related questions, read the full text using the QR code mentioned here. Should you have any question, we can discuss it after the talk, or you can reach me via email. Thank you for listening. This is Ayushi Rastogi signing off.